Hello, welcome to Geothermal Evaluation Prospect class. We will continue our discussion, and today we will review on the geoscience integration data for prospect evaluation. For references, I will be using these references. However, other references from a textbook or journal is very much recommended. By the end of this topic, you should achieve some of these competencies. Number one, should to understand geological, geochemical, and geophysical investigation that needs to be completed in a geothermal prospect area. And the second one is that you are able to analyze and integrate the 3G data from a geothermal prospect area and for you to give evaluation of how the 3G conditions of that certain area is. To assess this topic, we will give you a group assignment for you to assess the 3G data of a certain geothermal area that have been assigned. As I have mentioned before, I will use this graph as a benchline or a benchmark to our course. For this course, or for this session today, I will discuss this phase here for the surface survey, where the geoscience role is very prominent here, because the presence of geoscience data is very important to determine what kind of geothermal system that we will be facing in order for us to develop the projects. However, it is also will be repeated in the feasibility studies when we have done the drilling, because usually after drilling, we then retrieve more data to support the initial finding of the geoscience aspects. The output of the 3G data is for us to create an updated geological map, a preliminary conceptual model, and to propose a drilling and production site. This is all determined based on the geological observation, geochemical analysis, geophysical surveys, and also some reservoir engineering and modeling. However, usually just from these 3G data, the geological, geochemical, and the geophysical data, you then can actually create a conceptual model that actually depicts the subsurface condition of a geothermal area. For us geoscientists, the objective of geothermal exploration is to actually define the areas that are underlain by the hot rock, and also for us to estimate the reservoir of the volume, the temperature, and the permeability. Remember, in a geothermal system, porosity is not just important, but permeability of the lithology is also very important. Why? Because the permeability can actually determine how much water and steam is actually kept in a rock. Moreover, the objective of the exploration can determine the phase of the system, defining the nature of the fluid, and also to forecast the potential electricity for 20 years, because usually this is the amount of years for us to reach the break-even point. I will start off with the elaboration of geological survey. The aim of a geological survey is to create a geological map of the area and to actually determine the first draft of the conceptual model for the hydrothermal system. From the geological map, we then can determine the tectonic and the stratigraphic settings, the hydrothermal activities, where the faults are, or the structures, also to determine the distribution and age of the volcanic rocks, and to determine where the thermal manifestations are widely spread. From the geological map, we then obtain the stratigraphy, where stratigraphy plays a very important key to determine the depth and the thickness of the rock units, the faults, and the fluid flow paths. Moreover, stratigraphy can also help to assess the characteristic of the host reservoir, the dimension, and the geological activity of the region, because from here we can then deduce the history of the geological process in an area. Besides that, geological mapping is also important to determine where the thermal manifestations are widely spread. By mapping and documenting thermal manifestation, it is very important to determine the width or the dimension of the geothermal area, because we then can determine the geochemical work that needs to be done to estimate the potential of energy stored in a geothermal area. We usually create a base map based from the aerial photograph, topographic map, and plane table, and also remote sensing. From then, when we do field work, we can only go to the field and retrieve data from what we have prepared previously. From thermal manifestations mapping, we then can also do the hydrothermal alteration mapping, especially in the geothermal system. In geothermal system, the mineral altered is closely related to the type of fluid, the temperature, the pH, and the relative permeability of the rocks. By understanding the alteration, you then can determine the alteration zone. Each alteration zone can determine the type of pH, temperature, and the permeability of the rocks in the geothermal area. This is very important to determine the characteristic of the geothermal system. Overall, the exploration surveys in an active system comprise of the water survey, gas surveys, soil survey, mineralogical surveys, rock surveys, botanical surveys, and lastly, fossil or epithermal system. Please discuss with your partner or group the purpose, the type of data, and the results from these surveys, and how they can contribute to the building of conceptual model of a geothermal system. The second part of the 3G data integration is the geochemical analysis. Here, we use the principle of geochemistry, especially for geothermal system, to determine the characteristic of fluids found in the geothermal manifestations. The first step is for us to determine the fluid type. There are 5 fluid types of geothermal water. The first one is the neutral chloride water, acidic sulfide water, bicarbonate water, sulfide chloride water, and lastly the diluted bicarbonate chloride water. All these water determine the type, the lithology, and also the location of the geothermal system. From the geochemical analysis, we then can spread the data into a ternary diagram consists of the chloride, sulfate, and bicarbonate diagram, or some other ternary diagram that should support the findings. From geochemical analysis, we can also determine the geothermometer and the geoindicators evaluation. The purpose of geothermometer and geoindicators is actually to help you determine the outflow, the outflow, the condition, and the lithology of the geothermal systems. In here, we have to make a decision on where the temperature actually lies based on the findings of the thermal manifestations, the temperature, and other geological factors. And lastly, we have the geophysical surveys and investigations to complete the 3G data. Here, we have some useful geophysical techniques, such as the heat flux measurements, temperature gradient surveys, electrical resistivity surveys, seismic methods, both active and passive, and gravity surveys. The properties that are being measured from geophysical investigations include the temperature, the electrical conductivity and resistivity, the density, the velocity of wave propagation, magnetic susceptibility, and local gravitational acceleration. All of these properties are usually affected when it comes to geothermal system due to the change in the rock and physical properties. Geophysics investigation actually combines the geological map and data acquisition. To actually determine a geophysical model, we actually use the geological map as a baseline, whether to determine the stations or grid for data acquisitions. Moreover, the lithologies and the structure will help also to determine the dataset obtained, because we can then mark where we should actually make the cross-section for the geophysical model. Furthermore, geophysical models helps you to determine the target for drilling, because the model is actually aimed to determine where the reservoir boundary is. It is very important for you to determine the target for drilling, because then you will know where actually the reservoir is actually located. Furthermore, the model can also serve as a to predict the reinjection scenario, especially when you have come to the production phase. One of the methods in geophysical investigation is doing a resistivity mapping. Resistivity mapping can help you delineate the lithologies for the reservoir and also the temperature. Here we can see different type of lithologies based from the resistivity mapping. And this is the references that you can use because usually different lithologies have different resistivity values. Therefore, by understanding the resistivity value, you can determine the host rock for the geothermal system, and therefore you can determine the type of geothermal system that you are actually facing. Ultimately, all the geophysical data is used for mapping the subsurface. This is an example for subsurface resistivity mapping using the geophysical methods. Here we can then determine the lithologies, the heat flux, and also where the clay cap actually lies. In a geothermal system, clay cap is very important because it can determine the border and the location of the reservoir. By understanding where the BOC of, or as known as base of conductor lies, such as in this case, we can then determine the location or the depth of the reservoir. Therefore, sometimes in the geophysical investigations, understanding where the BOC lies is the key to a successful geophysical investigations. And finally, we have to combine all the data that we have retrieved. The geoscientific data from the geological, geochemical, and geophysics aspect we then collect and complete. And then we compose into a synthesis acquired data into a conceptual model. Remember, a conceptual model should depict the location of the rock units or the lithologies, the faults, the fluid flow paths. At least you have to have these three aspects in a conceptual model. This is an example of a conceptual model from Gunung Endut, Banten. As you can see here, you can determine the lithologies, the depth of the proposed reservoir, the location of the clay cap, and the proposed heat source. Based on this conceptual model itself, you can determine the type of the geothermal system, the type of exploration you should have, and also the temperature of the reservoir. Following that, you can then finally determine where to drill and how to actually exploit this geothermal area of the proposed project. I hope this course or this session will become useful to you. I hope to see you in the next session. Thank you very much for your attention.